All right, so here's the problem number 2, and in this problem we have to design an algorithm, or write a code to find the first common ancestor of two nodes in a binary tree. And so according to the definition of the first or lowest common ancestor, the first common ancestor could be considered if when one of the nodes is actually the ancestor of another. For example, if you are given this node and we are given another node, so at this time this 5 will be considered as the first or lowest common ancestor of these two nodes. So, and in order to solve this problem, actually I will declare three data structure. One is dictionary, where I will just connecting parents of all nodes while I will be traversing within the tree, nodes within the tree. Another will be a stack. To the stack I will be just putting the nodes that we will be considering within this tree, and the hash set, where I will be putting just ancestors of the particular nodes. So how we're gonna do this? So at the beginning we will start with the root node. So, and root node will go directly to our dictionary as a key, and as a value there will be just null. Then also at the same time I will push this root node element to my stack, and after that I will just keep iterating through nodes in the binary tree. Oh, I'm sorry. So for this particular example, for example, we are given one node. Let's assume it's 6, and another node, let's assume it's this one, Q. So we have to find out the common ancestor of these two nodes, and basically it means that we will need to find this node in our algorithm. So because the lowest ancestor of these two nodes is 3, as you see from this schema. And as I told you before, first our root node goes to the dictionary, and also it goes to the stack. Then we will iterate through each node in a binary tree until we find out the node that actually we're looking for. So at this point we'll just keep once we will find out, so at the same time, like I will just to traverse through the nodes in binary tree, I will just pop this element from the stack and save it as a node, and then I will go to the left of that node. So like here is the node, then I go to the left. If it's not null, I will add to the parent. So I will say that my node left, which is 5, and I will node left child will go as a key, and the node itself will go as a value into the dictionary. Then I will push the node to the stack, I mean the left child. Then I will do the same thing with the right node. So again, child right node will go as a key and the node itself as a value, and then I will also push the child of value to the stack. After that, I will keep moving until I find out my nodes that I'm looking for. So in this case, I already found for Q, but still I haven't found for P. So I will move to the next element. So my node will be here as a 5, and my 5 will go as a key, and no, my 5 left child will go as a key, and node itself will go as a value. Once I will find out this node, at this point I will just stop, and then I will go and try to fulfill this hash set. And into hash set, I will just add values of the P key value. So I will pass a node itself as a key value and pass the value from dictionary. So parent 6, which is 5, will go to hash set. Then I will just update my I will pass the P itself to hash set, which is 6. Then I will just reset my P as a parent 6, which will make my P equal to 5. Then I will again pass the 5 and will reset my P to parent 5, which is 3, so my P will be 3. Then I will pass a 3 to my hash set, and I will do it until my P will not be equal to null. Once it will be null, I will stop just. So parent 3 will make my P value equal to null. At this point I will stop, and then I will go and will reset my Q value, which at this point is 1. So I will go through my hash set and will go until it will be containing Q element. So basically it will be looking for Q equal to parent Q. Parent Q is 1, so Q will be equal to 3. Then we will see that our hash set contains 3. At this point I also will stop and will just return Q value, which is 3. At this point we will stop because we actually find out the common ancestor of these two nodes of 6 and 1, which is 3. So let me just write down a code for this problem. So I will call it, so it will return train node, and I will call it lowest common ancestor, and the inputs will be root, first node which is P, and second node which is Q. Then I will declare a stack which will be containing 3 nodes. I will call it just stack. Then I will declare dictionary which also will consist of nodes of a tree, and I will call it parent as I defined here in my at the beginning of this video, or let's call it parents. Then I will add first root node as a key and a null as a value. Then I'll also add root to my stack. Then I will start iterating through all nodes in a binary tree until I will find out my P and Q nodes. So I will do it in this as a follow, like parents contains key P, or if parents doesn't contain key P and parents doesn't contain Q. So it will make sure until we will find out all these 2 nodes in the tree, we'll just keep adding to our dictionary the key and values. So I will initialize a node which will be taken from stack. Then I will traverse in the tree and keep saving the parent pointers. So first I will go to the left, and if my node's left child will not be equal to null, so here I wrote all the code down, just keep my video paused just to write all these codes. So here I defining that until my node left child is not null, I will just keep adding into my dictionary node left itself as a key and node value as a value into a dictionary, and I will just keep pushing to my stack this left child. Also I will be doing the same with the right child, and after that I will declare a hash set, and from that point until my P will not be equal to null, I will just keep adding my P value to the ancestor hash set, and I will just keep moving, resetting my P according to the value from dictionary. So P will be always passing as a key, and the value will be resetting value of a P. Then until I will find out a Q in the ancestor hash set, I will be just keep resetting my Q value with the values from the dictionary, and I will be passing Q as a key value. And once my Q will be consist in the ancestor hash table, I will just return q. So time complexity for this particular example will be like order of n. In worst case, we'll go through all nodes in the binary tree, and the memory space we actually declared one stack, one dictionary, one hash set, so it will be like 3n, because 3 different data structures. So, and we can round up it just to order of n.